Bruce. Good morning, good afternoon, and good evening, everybody, depending where in the world you are joining us from. A very warm welcome. I think most people here know me, but my name is Connie Clare, and I'm the Community Development Manager at the Research Data Alliance. And I'm really delighted to be your host for today's quite intimate webinar, which is organised by the RDA, but also in collaboration with the Ethical Data Initiative, or EDI. So today's session is titled Recommender Systems for Social Good, and we're very fortunate to have a wonderful speaker with us today, Dr. Silvia Milano, joining us. And before I introduce our speaker, just a few housekeeping points for the next 45 minutes. The webinar is being recorded and we will make it available on the RDA event page next week after the next session. So you will be able to revisit it and share it with your colleagues. We will have time for a Q&A, so please do feel free to drop any questions you have for Silvia on recommender systems in the chat, and we will try to address as many of those as possible at the end. Silvia has approximately 20 minutes or so for her presentation, and the entire session is to run to around 45 minutes. If you do have any technical difficulties, please do let us know. Just to remind, this is an RDA organised event, so we will be adhering to the RDA's code of conduct, so please do be respectful and listen openly to the perspectives shared. And I know you are all members of the Research Data Alliance here, but of course, as you know, the RDA is free and open for anybody to join, and I will share a link in the chat for that shortly. So now it is my great pleasure to introduce Silvia, who is our speaker. So Dr. Silvia Milano is the head of research at the Ethical Data Initiative in Munich, also known as EDI, and this is also a valued affiliate member of the Research Data Alliance. So Silvia's work is really sitting at the intersection of data ethics, technology, and the social impact of algorithmic systems. Silvia will be sharing her research on recommender systems. These are the algorithms that power platforms that we're very familiar with, such as Netflix, Spotify, and social media that suggest content to each of us. And while these systems are often designed to maximize engagement, they can tend to prioritize business goals such as clicks and revenue over what is genuinely good for users and society at large. So Silvia will argue that we need to move beyond simply making these systems more accurate and instead design them to better support fairness, diversity of viewpoints, and people's ability to make their own informed choices. So this is a very timely, important, and fascinating topic, and one that I'm sure impacts all of us in our daily digital lives. So Silvia, thank you very much for being here, and the floor is yours. I'll let you share your screen.
Thanks for the lovely introduction. Let me quickly share my slides.
Wonderful, thank
Can you
you.
see my slides?
We can see them.
Perfect. Thanks, Connie, for the introduction, and welcome everyone. So, as Connie just mentioned, I am joining as member of the Ethical Data Initiative. I had the research on the TOM side. This is an initiative that is shared between the University of Exeter and the Technical University of Munich. And I'll say something about what we do before I get into the research spotlight that we have on recommender system currently that I'm working on. So the Ethical Data Initiative is a non-partisan platform fostering open discussion and collaboration around data ethics and responsible data practices. And we do many things. I will refer you to the website where I hope you can find more interesting information and maybe join as an affiliate. But everything we do is connected to policy networks, education, and engagement, and is grounded really in research. So research is the heart of what we do, and then that grounds all our other practices. But what do we mean by data ethics? Since we call ourselves the Ethical Data Initiative, we wanted to be clear about what we mean by data ethics, and we recently, me and the other core members wrote a short article just to outline our vision, and we mean by data ethics something that is not a universal set of principles. You won't catch us giving, checklists, but we see it as a living ethos. And in this context, we want to think and we want to be a catalyst for others for thinking about what decisions are made at every step on a data journey. So when data is collected, stored, reused, interpreted, enriched, modeled, and integrated, how all the decisions that go into like working with data at every step must be sensitive to the implications that they have. We think that this is where ethics comes to life, ethics as a practice, because oftentimes ideals and abstract values will be in tension and there will be no uniquely right way to approach the decisions and to apply the ethical principles. So it's very important that we think of this as a practice where openness is higher value than just ownership of the decision. But I would refer you to the article if you want to know more about our approach and to the EDI website in general for more information about our activities. There's many resources. I will go quickly because we don't have a lot of time. And I also want to flag that there's a new Birds of a Feather group that is going to be launching in collaboration with RDA, Codata, WDS, and EDI. So please, if you're interested in these, keep your eyes peeled. So, but today I want to talk specifically about the research strand that we have on at the moment. We just recently launched this year on recommender systems for social good, which is what I have been personally interested in recent months. There's a link to a blog post about this on our website. Oh, it's not going forward. I don't know why. Okay. Okay, so recommender systems, as Connie was mentioning, are pretty much everywhere in our online lives. So when we are online shopping on Amazon or other e-commerce websites for that matter, when we are being entertained, or when we are communicating or being in touch with others on social media, as well as when we are doing research. Increasingly, recommender systems structure the way in which we access information, not just in entertainment or e-commerce context, but here I have the example of Google Scholar recommending articles. It's an example of how recommender systems are nowadays also part of how we conduct our research. If you are using any type of algorithmic system to keep up with recent publications in your field, then you will be interacting with something that is in the scope of the talk today. So they are literally everywhere. And why do we think as EDI, Ethical Data Initiative, that we wanted to put the focus on them? Well, because I would argue they are the entry points into the AI data nexus. So they are underpinning many AI applications. They shape how people access information, access opportunities, and access services. And yet they are still optimizing primarily for goals that are not necessarily ethical. Or so, for instance, user engagement, user retention, or monetization on the part of the platforms that develop them. So, in this research strand, we wanted to explore how to move beyond this framing. And we realized that this means moving beyond an accuracy first paradigm that is currently prominent in the field and to rethink recommendation systems in terms of their social value and their public interest. So before I explain what this shift I think needs to be, I want to give you a little bit of history. I'll be very quick, but to understand how we got here today. So the history and the present landscape of recommender systems field. So what is a recommender system? Probably all know, but just to put it, outline it in a bit more abstract way, it's an algorithmic system for filtering information based on inferences that are drawn from large data sets. So typically there will be catalogs with many thousands of potential items that and then users accessing this catalog needs some guidance to find something, surface something that is relevant, and typically this is a recommender system. And the way that it works is that it learns to filter and surface things that are imputed to be relevant to users based on inferences that are drawn from how other users have behaved in the past in relation to similar items. Recommendation is different from search because search is based, so for instance, when you do a Google search or another search engine, it's based on a user query. So the user actively provides a string that is then used to surface content, whereas recommendation is generated for a user, and the user in this sense is passive. The only action that a user has to make in many of the instances that I gave as example is simply to log in to the platform, and then their user data is used to automatically generate some recommendations. Of course, they can be on a spectrum. We can have, of course, personalized search or search augmented recommendations. So they are, of course, on a spectrum, but we can see them as two polar cases. So where recommendation is generated for a user and the user is passive in this type of applications. So historically, they haven't been around for that long. Of course, the principle of filtering and recommending something is arguably as old as culture itself, but algorithmic systems that are meant to automate this practice are relatively recent. So maybe one of the earliest examples of a study that was starting to look into this is this paper on user modeling by stereotypes from the late 70s, where the author was exploring formulating recommendations on the basis of inferred stereotypes about the users. But it's only really from the 90s that recommender systems research took off, and with some specific events that catalyzed it. So the most obvious thing to point at historically is the Netflix prize. So at the time, Netflix had decided that they had a database of user ratings, and that they instituted a prize to get the community thinking about how to use that data set to formulate recommendations. At the time, they were, of course, not a streaming platform, but they were a DVD rental company, and they wanted to send off DVDs to their users that were maximizing some kind of expected relevance for the viewers. So they published this data set. There was a lot of interest, and this specific historical development highlights several things. As I said, this is where we can date really when research on this in this area took off, so from the 90s, and it's tied to the availability of large data sets, which are specifically on user interactions. So Netflix had catalogs of DVDs and was recording how users that had watched them were responding to them, so what rating they gave and what they requested afterwards. So this highlights a few things. So the reliance on behavioral data, that is what the algorithm in the Netflix prize was trained of, is also something that comes up over and over in subsequent application. And of course, this is tied to increasing surveillance of the users, because as we move to online platforms, this meant also this kind of behavioral data has been harvested in more systematic way, and this has become to form really the backbone of any recommender system application. There's more things that I could go into, for instance, how the history of recommender systems is tied to encroaching on user privacy, and how all the initial applications were of a commercial nature, skewing in a way the way in which the problem is approached and the goal is formulated. But we can come back to this later on, or also in the Q&A. So I wanted to also highlight that there are different approaches to recommender systems. So on traditional methods, they include approaches like collaborative filtering or content-based or hybrid types of approaches. These traditional methods rely on, as I said, large user data sets and specifically user surveillance to function. And they are built to recommend items that are already existing in the catalog. Their training has to happen with respect to a specific data set. On the other hand, with generative models now, we are starting to see different types of approaches that are becoming available. I cannot go into too much detail, but I refer to a recent book that we published on this topic, outlining exactly how these systems are working. But with generative models, it's possible to have multimodal recommendations. They might require less user data because the training of the model itself happens on different data sets. They rely, they can rely on pre-trained models. And also, they're different from traditional methods in that they can generate new items just based on the user profiles. So instead of recommending things that are already existing in the catalog, they can make up something just for the user. This might be relevant in e-commerce, but also in entertainment. And of course, it has interesting commercial applications, but also very obvious ethical risks that it disposes. So the way in which the algorithmic task is approached, I would argue, is anyway always the same, and it can be split into several steps. So the first one is a prediction task where the recommender system is modeling users and making predictions about how they will interact with different items that are on the catalog or that can be presented to them as a recommendation. And then this is used as the basis for a display task. So deciding what the user is going to see. So the prediction task is always, in the current paradigm at least, the basis for any subsequent recommendation subtasks. The prediction task is based on the available information. And as I said, the aim is to predict how a user will interact with items that are available for recommendation or how they might interact with something that can be generated in more recent application. And this forms the basis for subsequent tasks. Already we can see how these is grounded really on the history of how recommender systems came about and the fact that they developed out of user interaction data sets. But there are other stakeholders in the recommendation. I will come back to these later, so don't worry that the image is quite small. But I just want to flag at this point so it's already on our mind that this framing is very user-centered, but the stakeholders in a recommendation include other parties, like, for instance, the provider of the items or society itself, which can experience, of course, effects or externalities. So prediction and recommendation are very intimately tied. As I said, the prediction task is the first step, and it's considered to be the most central. And here is how a couple of researchers that are very prominent in the field articulated this idea in a paper that was considering the state of the art a few years ago. So the most important dimension for researchers is being able to accurately predict the relevance of individual items to consumers with the goal of presenting the assumedly most relevant ones as recommendation. And in this framing, to judge a recommender algorithm is to judge how accurately it is predicting user preferences. Everything else can come in and can be counted as a side constraint and can be integrated at some subsequent steps, for instance, at the display step, as side constraint. But really what forms the core of the recommendation problem is this prediction of user relevance. Of course, this paper is quite critical of the status quo, and that's what I want to put the focus also on today. So this focus on accuracy and accuracy ranking for algorithmic recommenders. I think we need to question. I'm not the only one, but let's talk about this. So, why is it so important to be accurate? Studies indicate that the results from offline experiments, so other ways of evaluating how well a recommender system is doing, that are not based on implicit user feedback, they are not indicative of the effectiveness of an algorithm in practice. So it's not necessarily what, for instance, commercial companies use to evaluate their algorithms in production. And unlike other applications of machine learning, so for instance, automated translation or image recognition or any other cases where algorithms have to make decisions, higher prediction accuracy in the case of recommender systems doesn't necessarily lead to a better system. We can give some examples to draw this point intuitively. So, for instance, when recommender systems are used to explore content, be it in the case of music or in the case of news, we don't just really want to predict the past and to match accurately what a user preferences have been in the past. This might be because we also want to use recommender systems to develop our taste or to access something new, and sometimes it's fine to make mistakes, as in the case of music. Or it's because, as in the case of news, there's also something else to balance, which might be a more collective perspective. So, what readers of news need to know, and how individuals need to be informed in order to be a good part of the epistemic collective. So it's not only important to predict them accurately, but also other goals that are a bit more difficult to articulate enter into determining how good the recommendation is. So if the personalization is an aim, well, this is what is currently mostly assumed in the community. Accurate and personalized recommendations are often credited for increasing business and user satisfaction, at least anecdotally. Even public service media, I will say, I worked a little bit with the BBC some years ago, increasingly see recommendations as a way to reach audiences and to then satisfy their mandate.
Sylvia, you've got 5 minutes if that's.
Okay, I'll try to go very quickly. But these claims are not often substantiated, and in actuality, there's also a dark side. Algorithms are often used not for the most accurate, but they're responding to business goals. So focusing solely on personalization obscures the interest of other stakeholders in the recommendation. These are sometimes treated as a side constraint, but this introduces issues of appropriate justification, and then commercial interests are concealed in the choice of proxies for user preferences. So this makes the whole exercise quite intransparent. So it seems like personalization then is quite an excuse, seems to give rise to problems, and encouraging collection of large surveillance data sets. Focusing on predicting users obscures what are the real interests of other stakeholders and complicates the justification for other side constraints. And also, this doesn't negate that it's possible to build applications that are genuinely good, but this is obscured especially in the academic work. This is not just a user problem, but it requires thinking about recommender systems sit at the nexus of different stakeholders with different interests as well. Okay, so social good and the purposes of recommendation. How do we go about changing the state of the art in here? So, as I said, the state of the art currently sees a split between academic research and commercial applications, where academic publications focus more on a narrow set of case studies and data sets, where great importance is given to small improvements to accuracy metrics. But in the real world, of course, the systems in production look at are maximizing for other things, and the side constraints are very stringent. So we have some key questions if we want to think about recommender systems for social good. These are I would include how can recommender systems account for multiple stakeholders, how we can articulate this notion of social good, what does it mean, especially in the recommendation context, and how can we design systems that support different good things like fairness, diversity, autonomy, societal well-being, and a judicious use of environmental resources. I say that we need to operate a conceptual shift. So while in the traditional view, we are in this outlook of finding the most relevant item to the user, we need to shift this to viewing recommendation as a normative choice architecture. So starting with identifying the stakeholders and making the trade-off at the start of the exercise that then guides what data is useful and how to structure the recommendation problem. So there's several examples of you trying to use and researchers trying to articulate visions for recommender systems for social good. I linked to a paper that I think is doing a very good service of gathering up several of these examples, but I will go very quickly on this now. So I think they can be classed into two types. So the first type is looking at trying to limit or correct negative aspects of existing recommender systems, whereas the second type, which is probably more interesting for us, looking at brand new applications designed from the outset for social good, where social benefit is the core design goal from the start, not a side constraint. And yeah, I have the slide, and we can go about the examples in the Q&A. There's one thing is that the same application domain can fall into either category. It depends not on the application itself, but on the underlying goal. There's several challenges to operating this shift and designing recommender systems for social good. And I would say this cannot be solved in the abstract. As I said in the beginning, ethics is a practice. And so this will need to be articulated specifically for the domain that the researchers is looking at. So these include defining what the good is, so settling some normative questions, measuring utility or interest or any other evaluation metric across different stakeholders, choosing the right level of abstraction. Because it might be that when you look at individual or group outcomes, there might be competing ways of formulating the same recommendation problem, and then also avoiding paternalism and feedback loops. So how do we get there? I outline a few avenues and of course would be open to discussion about this. The first one, very important, I think, is to reconsider what benchmarks are used in the research. So there's a widespread reliance on just a few openly available data sets that are used to train the models, to test them, and they're mostly linked to commercial applications for the historic reasons that I outlined before. I link here to a couple of databases. So the availability of these data sets has been the catalyst for development in this field, and it has both advantages and very prominent risks that now are becoming even more obvious. So the advantage is, of course, it makes it possible to compare different algorithms, makes it possible to have reproducible research. But the risk then is that it orients research towards specific types of applications, especially with commercial traits, given the nature of the data sets that are available. And there is not, I would argue, enough critical reflection on the provenance of this data and how the results transfer to other domains. So generalization is assumed, but it's seldom proved or contextualized. So in the face of this, we should try to think about maybe including different data sets or collaborating in multidisciplinary way with other types of figures outside of recommender system development, strictly speaking, to access data sets that are more attuned to the kind of application that one wants to build. And also this includes defining methods for more continuous evaluation. Why? Because we need really to think about how the interests of different stakeholders are represented and consider participatory methods for defining the system's goal and agree on specific evaluation metrics that might be linked to maybe availability of new data sets that represents different side of the evaluation problem. So they could be integrated at the step of the prediction exercise. Also, it's important to note that many of the relevant effects of recommender systems depend on systemic features, such as, for instance, the size of the platform or the average use, which cannot be measured in abstract, in isolation, and prior to deployment. So this needs to be done through a continuous evaluation exercise. Then I would say that we need to consider the goal first and the data second. This kind of follows from my previous point. So we cannot assume that a data set is a neutral representation of users and their preferences or of the characteristics of items. We have to consider how a data set was created and how using it might impact the recommendation pipeline and different stakeholders. And we used to treat the data contained in the data set as evidence of situated dispositions, not fixed preferences. So generalizations need to be based on reasonable assumptions and grounded in a multidisciplinary argumentation. Then finally, I think something that is prominently missing in much of this research is tracking environmental impacts. So it's we should consider whether the resources used to provide recommendations are well spent. And increasingly, studies are showing how advances in recommender systems are correlating also with making them more resource intensive. Even small gains in accuracy can have enormous environmental costs, and often this is not a trade-off that is worth making. So it's important to develop tools to document the energy use of a system in both training and deployment and how it correlates with other objectives. So I linked here to one tool that is currently available, and I think others might be coming up in the pipeline. So a comprehensive evaluation, I think, of a recommender system should account also for the environmental impact and treat this as an explicit trade-off to allow for more transparent, contestable, and governable trade-offs. So that brings me to read the conclusion of this talk. I've outlined a bit of the history of recommender systems, why it's important to think about them, and why I think we should operate a shift from a user-centered and accuracy-based perspective to viewing them more as a decision infrastructure. And I look forward to questions from the audience. So as EDI, we have the following events going forward. And if you're interested in our research, please consider becoming an affiliate. Thank you.
Thank you, Sylvia.